Welcome. Yeah, so there are 3 videos on limits of this sort, and you should watch those videos before watching this. So I'll link those videos below this. All right. Now to start here, what we should do is let y equal. We should let y equal 1 plus 1 over ax to the power a, right? So y is this here, yeah? Okay, cool. And then we should take the natural log of both sides of this. So on the left, we'd have the natural log of y, right, is equal to, on the right, we'd have a times the natural log of 1 plus 1 over ax, right? And yeah, so if I'm going too fast for you here, you should watch variety 1, which I'll have a link to below this video, yeah? Okay, and after this, we should write lim is a goes to infinity right here, and so lim is a goes to infinity. Now, for reasons you'll understand very soon, here, instead of multiplying by a, let's think of it as dividing by 1 over a. And multiplying by a is the same as dividing by 1 over a, so it's all good, right? All right, so we have this here. Okay, now, as a goes to infinity, what happens to this quotient? Well, as a goes to infinity, this here, 1 over ax is going to go to 0. So the numerator is going to go to ln of 1 plus 0, so the natural log of 1. But the natural log of 1 is 0. So the whole numerator, as a goes to infinity, is going to go to the natural log of 1, or 0. And then as a goes to infinity, 1 over a is going to go to 0. So we get 0 over 0, which is an indeterminate form, which will allow us to use L'Hopital's rule. So L'Hopital's rule would then tell us that this limit here is the same as doing limit as a goes to infinity, as a goes to infinity, of the derivative of this numerator divided by the derivative of this denominator. Now, the derivative of the numerator is going to be 1 over, it's going to be 1 over 1 plus 1 over ax, right? But this times, by chain rule, times the derivative of that. Now, the derivative of 1 is 0, but the derivative of 1 over ax is going to be, it's going to be 1 over x times negative 1 over a squared. Now, I'd imagine that a few of you are going to be confused by what I just wrote. Yes, let me explain. Now, this here y is a function of a. So the variable is a. So x is like a constant. So when we're looking at the derivative of 1 over ax, it's as if we have 1 over x, a constant, times 1 over a. So the derivative of this, which is the same as the derivative of this, is going to be like, leave the constant alone, which I've done right here, and then multiply by the derivative of this. And the derivative of 1 over a is negative 1 over a squared. But yeah, all of this here, let me do it again. All of this here, right? This here is the derivative of that. So we have to divide it by the derivative of the denominator before we send a to infinity. And so the derivative of this, well, we just did that. It's negative 1 over a squared, right? Okay, cool. So next we do this. We see that we can cancel here and here. And then we evaluate the limit as a goes to infinity. As a goes to infinity, as we already said, this here goes to 0. So this whole thing is going to go to 1 over 1 plus 0, or 1. So we'll have 1 times 1 over x, and then these guys are gone, right? These guys are gone, right? So we just have 1 times 1 over x as a goes to infinity. So that's just 1 over x, right? Okay, so this limit here is equal to 1 over x. But wait, since this limit here is the same as this limit here, right? We're saying that this here goes to 1 over x. So let's get rid of the no longer useful bridges. These guys, right, they're just a bridge, right? So we don't need them no more, right? Okay, so we do that, and we realize that this here is equal to 1 over x. Now, from here, as we did in variety 1, we're going to recall that this here is the same as the natural log of the limit as a goes to infinity of y. So notice that what I've done to go from here to here is I've put the limit inside of the natural log. So I put the limit with the argument, and we're allowed that. It's a limit rule that allows us to do that. So this is equal to 1 over x, right? Okay. Now, since what I'm after is the limit is a goes to infinity of y, and therefore the limit is a goes to infinity of that, right? That's what we have right there. Since that's what I'm after, I want to get rid of this ln that's in the way. So to do that, I do e here, so I can cancel, and so I see the limit is a goes to infinity of y, so limit is a goes to infinity of that, which is limit is a goes to infinity of that, which is this, is equal to e to the 1 over x as desired. Yeah? Okay, cool. All right, I hope you enjoyed this, and keep watching. Yeah.